go to problem 8. Let's try to solve this trigonometric equation together. So we can see the question is mainly about tangent. So before doing it, let's do some review about some properties related to tangent. So tangent, So first, let's review the graph of tangent. Let's quickly sketch what tangent x look like. So this should be something basic, I would say. So I won't give so much explanations. We write to pi over 2, pi 1.5 pi to pi over 2 pi. Sorry, the space isn't enough, but I think it will show the idea. It's important which of the symptom it goes. Sorry, I shouldn't use. Yeah, I mean, this is beautiful. This is what tangent graph look like. It's important that you can draw it anytime, anywhere. It should be useful during the exam. Let's recall some properties. So property first is tangent. The first basic is cotangent x equal 1 over tangent x. It's a reciprocal of tangent x. And tangent to pi minus x should be the reciprocal of tangent x. Do you see some relations? Yes, this is correct. Cotangent x equal tangent to pi over 2 minus x. Pi over 2 means 90 degrees in degree. How to prove this is quite simple. We can give an instinctive proof by setting it in a right triangle. This will be x, this will be pi over 2 minus x, and this tangent x will be b over a, and tangent over 2 minus x is equal a over b, and when they multiply together, you know that it should be just 1. So we give the quick proof, but actually this works for any x, and that requires a proof which is more comprehensive, but we don't have time and space here, so let's move on. The other property should be tangent, how to expand tangent a plus b. This is tangent a plus tangent b over 1 minus tangent a times tangent b. A typical result, so a special case is tangent 2a. So we just give it like this. It's important you memorize these two. This is very important. So I think we have done the review part, so let's look at these questions for real. Show that if tangent square theta equal to tangent theta plus 1, then tangent 2 theta equal minus 1. We can we can fairly say after the review that this looks very much like the formula here. Let's do some algebraic things. So let's -1 equal 2 tangent theta. No, let's compare. I mean, we want the 2 tangent theta on the top. 2 tangent theta equal tangent square theta -1. 2 tangent theta equal -1 times 1 minus tangent square theta. And this gives us 2 tangent theta. Sorry, we shouldn't write on the question. And this just directly gave us 2 tangent theta over 1 tangent square theta equal -1. On the left hand side, it's just exactly tangent to theta. In our review, we have just said about it. We just talk about it. So yes. Question 1 is super easy. Let's look at question 2. Find all solutions of the equation tangent theta equal 2 plus tangent 3 theta, which satisfy for theta is in the interval from 0 to 2 pi exclusive. So expressing your answers as rational multiples of pi. Okay, so tangent 3 theta. Now we know that we should expand tangent 2 theta because we cannot deal with tangent 3 theta directly for this question. So let's try to do some expansion. Tangent 3 theta obviously equals tangent theta plus 2 theta. And it will be tangent theta plus tangent 2 theta over 1 minus tangent theta times tangent 2 theta. Here, we just realized that we are going to write tangent theta for a lot of time. So to make the proof writing more easy, we're going to let tangent theta equal t. Therefore, tangent 2 theta will be, so it's 2 theta minus 1 minus tangent theta, so be 2t minus t squared. So let's keep our writing for tangent 3 theta. Sorry, I don't write it so beautiful. So it's 2 plus 2t over 1 minus t squared, 1 minus t times 2t 1 minus t squared. We're just doing then this might be the part that requires some basic skills. Just watch. You can skip this part if you don't want to watch. So you cancel this 2 out, become 3t plus 2t squared. Okay, this would be square minus 3t t squared minus 1. Okay. The original function is tangent theta equal 2 plus tangent 3 theta. So we get them back. T equal 2 plus t cubed minus 3t over 2t squared minus 1. I would say this is just pure calculation. No skills, just calculation. Say when you are doing something called pure calculation, you should do it with 100% concentration, because I have just made a mistake. How I realize is because when I expand it into some functions, I cannot find a proper or rational root. So that would be a problem. When I go back, I find out I make a mistakes here. So let's just correct some mistakes, and I hope this gives you some kind of warning. I don't know. It's just 3t squared. 3. Okay, whatever, let's go. 3t squared minus, okay, it's just no talking, okay, no talking. I don't want to make any more mistakes. I have to admit that I am scared. Okay. Oh, squared. No way, bro. No way. Now I'm very confident because look at this, look at this. When we are seeing functions with high degree, with complex polynomial functions, we have to guess the root first. We guess roots like 1 minus 1, 0, 2 minus 2, something like that. And for this, within a second, we can tell that t equal 1 is a root because 1 minus 3 plus 1 plus 1 equals 0. And if we get this, we can kind of say, I think, we didn't make a mistake during the calculation. So we factor a t minus 1 out, and this t squared, and we get minus 1 here, and it's minus t squared, 2t. You can do it like me, or you use non-division. Non-division might be safer, but this way, it can be quicker. For this, so let's get tangent theta back. Okay, let's get our tangent theta back. So the first part is tangent theta equal 1, because theta is in the interval from 0 to 2 pi, and we know that let's write it in the, okay, we don't have any saves, but for tangent theta equals c, okay, tangent theta equals c, theta will equal arctangent c plus n pi, because the period of tangent x is pi, and during that period, tangent is strictly increasing. So we can write it in a very simple way. That's the solution. We know arctangent 1 is pi over 4, which is pi over 4, which is 45 degrees. So we can write theta equal, this gives us theta equal 1/4 of pi. We plus a pi on the first solution. We get the next solution, 5 over 4 times pi. The next one should be 9 over 4 times pi, but that is out of the interval. That is more than 2 pi. So we abandon that one. Let's look at the next part. This will be tangent square theta minus 2 tangent theta equal 1. And let's look at the first part question. That is exactly the same. So tangent to theta equals minus 1. We want to apply the same formula here, so we want a new interval for 2 theta. So 2 theta should be in the interval 1 to 4 pi. And, the original theta, which is 2 theta, which should be arctangent minus 1, should be exactly minus pi over 4. But this is not in the interval, so we have to move on. Pass it a pi, and it become 3 over 4 pi. Yes, and 7 over 4 pi. Is it correct? Can write until 16. Yeah, that's the end. That's the end because the next one should be 19 over 4 pi. which exceeds our limitation of 4 pi, the upper bound of 4 pi. So theta will equal pi pi. Hence, pi 7 pi 5/4 pi 4 pi. Yeah, that's the end for problem 1. That's the end for question 1. The only difference is it used cotangent instead of tangent. But what's the deal? We still substitute tangent theta into it. We still use the substitution. It's totally the same. From the beginning to the end, it's totally the same. I don't see any difference. It's there. So I have done all the calculations, I have to say. And this is my scratch paper. And how it might look like. In fact, I have to tell you that in real exam, you don't have to write like this. You don't need to write all this calculation. You can just show it within one line. You don't have to show them on the paper. I write it like this to make the whole process more authentic. That's the end. That's fine. I mean, I just noticed that maybe I should. Never mind. Let's move on. So we made the substitution. We still let t equal tangent theta. So cotangent theta equal 1/t. For tangent 3 theta, we just substitute the reciprocal of tangent 3 theta. That's it. That's all. And we get this thing. We get that thing. In the end, completely the same. For the first thing is tangent phi equal 1. So in the interval, we have only like pi/4 and -3/4 pi. For the next one, tangent square phi plus 2 tangent phi minus 1 equals 0. Yeah. We have some inspirations from the previous questions. We try to make it in like the tangent 2 phi thing, so it simplifies the calculations. And yeah, we get this. This gives us tangent 2 phi equal 1. And tangent 2 phi equal 1, what it gives us? It gives us 2 phi. So we have to make it. We still need a better interval for 2 phi. It would be -3 pi. -3 pi to pi. So we start from pi/2. Oh no, pi/4. Pi/4. We subtract until -12. Okay. -4/11. Yeah, no more subtraction. The next one should be 15, and that just exceeds our lower bound. The upper bound, let's keep adding up. Pi 9/4 pi. Oh no. No more. This is so we cannot add anything from there. This is the end, I guess. So we get phi equal pi/8 minus 3/8 plus 7/8 minus 11. Hence, phi equal. Sorry. Pi. Sorry. Pi minus 3/8 pi 8 pi/4. Yes, that's the end for the solution to problem 8. Thank you for watching.